All right. Hi guys, hopefully this works a little better. This is the way I recorded things last year, so I'm hoping we can use this again. So today we're taking notes on 1.2 part 2, and they're not too long. So it's about a few different laws that we're going to use that have to do with numbers. We've talked about some of these last year, and some of these you might just kind of already know just from talking about numbers. So the first thing we're going to talk about is the commutative law. Now what this states is it works for both addition and multiplication. So it says that if you take any number a plus any number b, that's going to be the same as if you do b plus a. So I think last year when we talked about it, we talked about how you commute back and forth to work or school, and this says that you can add back or forth. So this is the commutative law of addition. And this works with one other operation. You might be thinking of what it is right now. It also works with multiplication. So if you take any number a and b and multiply them, like 2 times 3, that's the same as 3 times 2. So that's the commutative law of multiplication. You can multiply things back and forth in either direction, and it doesn't matter. It does not work with subtraction or division. So what the commutative law helps you form, and we talked a lot about this in 8th grade math, is that it helps you form equivalent expressions. Equivalent expressions. So equivalent expressions are two expressions that have the same value for all possible replacements. And when they say replacements, they're talking about if you replaced a variable with something. So for example, if you had the expression, I'll go back up here. If you had the expression x plus y, it doesn't matter what x and y are, no matter what you replace them with, that's the same as y plus x. So this and this are equivalent expressions. And you can use the commutative law to write commutative expressions. All right, so we're going to do an example next. So an example that you might get, and I know these notes are a lot of words, it's very wordy. An example that you might get might say something like this. Use the commutative law to write an equivalent expression to 7x plus 9. So we're going to try and use the commutative property, the property that says we can go back and forth, to write something equivalent to 7x plus 9. So there's two ways you might do this. You might say, well, I know I can add things in the different order, so I can just change this to 9 plus 7x. That would be using the commutative law of addition. That's equivalent. You might go a different route, and you might say, I want to try and use the commutative law of multiplication because this 7 and this x are being multiplied. And you might just say, I want to switch those around because it doesn't matter which order I multiply 7 and x. So you could say, I want to do x times 7 plus 9. So those are two ways to do that. So that's the commutative law. Back and forth, it works for addition and multiplication. So now we're going to go on to a law called the associative law. Now this law has to do with grouping. So I'm going to write under here, changing by grouping. So this is just saying that you can, if you have, maybe you're doing 2 times you're doing addition, it says that you can group things in any order. This will make more sense when I write it here. So this could look like this. Let's say you're doing A plus, and then in parentheses, B plus C. Well, if all you're doing is adding, it really doesn't matter what order you're adding all of those things in. If you're doing 1 plus 2 plus 3, it doesn't matter what order you add them in, it's going to be 6 no matter what. So the associative law says that you can do A plus B first, and then C. And that's the associative law of addition. Now this doesn't just work with addition, it works with one other property or one other operation. And you can probably guess what it is based on the last one. It is multiplication. So this says that if you're multiplying 3 things together, like A times B times C, and if you have parentheses in it around the B and C, it says it doesn't really matter that the parentheses are right there. If you're multiplying, you can do A times B first and then multiply times C. It doesn't really matter. It's going to end up being the same anyway. So that's the associative law of multiplication. So one example you might get is, again, we're going to try and write an equivalent expression. So this, again, forms equivalent expressions. So here's an example you might get. It might say, write an equivalent expression for, in parentheses here, 3x plus 7y plus 9z outside of the parentheses, using the associative law of addition. So basically, you just change the grouping here. So instead of grouping around the 3x plus 7y, we can change it to be grouped around the second part of this equation. So we can say, well, this is equivalent, 3x plus, and then in parentheses, 7y plus 9z. So that's the associative law. So you can kind of remember it like, who's associating with who? Who's grouped up with who? So you're changing the grouping. Now we've got one more law today, and we did it a lot at the end of last year. It's the distributive property. Actually, I should have said the distributive law. But you can call it property too. Our book just happens to call it law. So remember problems like this last year? I'm just going to use A, B, and C for now. So they would have looked like this. A times the quantity B plus C. So if you remember what we did there, that means that A is not just being multiplied to B, it's being multiplied to whatever B plus C is. So if you don't know what B plus C is because maybe you're using variables or something, this means that you can we did kind of a rainbow motion. So we're going to do A times B first, which we're just going to have to write as AB. And then we're going to do A times C, which is just AC. And then we just put these together using addition or whatever sign we end up with. So that means that using the distributive law, we can rewrite this as AB plus AC. All right, so these two things that I'm about to highlight are equivalent. This is equivalent to this. Whoa, I really messed that one up, didn't I? That means that there we go. Now we can see it. Those two expressions are equivalent by using the distributive law. I'm hoping you guys remember that from last year. All right, so let's do an example for that so you guys can practice that. All right, I want you guys to write an equivalent expression to this by distributing, okay? I'll do this one with you, and then I'm going to give you 2 to try on your own for homework. All right, so to distribute, we have this term out here. Remember how much I love the word term from last year? And we have 2 terms in the parentheses. We need to multiply this term by this first term and the other term in the parentheses. So first we need to do 5x times y. Now we can't really change that too much. That's just 5xy. Now we need to multiply the 5x by the 4. So now we're going to have to multiply 5x times 4. We've got two constants here, 5 and 4 being multiplied. We can multiply those. 5 times 4 is 20, and we just attach the variables onto the end. So we can rewrite this, I'm going to go down here because this recorder's in the way, as 5xy plus, because this part's positive, the 20x, 20x. So this right here is called expanded form. Okay, so we expanded it out. And this first version is called factored form. Right? Because the parts of a multiplication problem are called factors, and we have two factors here, this and this. They're being multiplied, so that's why it's called factored form. So I want you guys to try writing two expressions in expanded form. I'm going to give you them in factored form. All right, so I want you to distribute, in this case, the 3 to the x plus 1. And for b, I want you to try distributing this negative 2x to x minus 7. That one's tricky with the negative, so be careful with that one. All right, try both of those, and we will check those next time we're in class. I've got one more thing for you. So like I said, these are in factored form. So sometimes I'm going to do the opposite. You're going to get the expanded form, and I want you to factor this. All right, so we want to undistribute it. So we have two terms here. We want to figure out what can we divide out of those to put back in the front, to factor out of it. So you want to think, well, what do 3 and 6, what factor do they have in common? Hopefully this one's easy because 3 goes very nicely into both of those, doesn't it? So we can divide out a 3, so we put it out here. Now just open up your parentheses and think what would go inside of there. So to get this 3x, what do I need to multiply the 3 by right here? Well, I just need to multiply it by an x. So I'm going to put an x right there. Now right here, I need to think, okay, I've got a 3 on outside. What am I going to multiply that 3 to get negative 6? All right, so 3 times negative 2 is negative 6. So I'm going to put minus 2 here. I'm going to rewrite my answer more neatly. 3 times x minus 2. That's the factored form of our original expanded equation. Okay, and you can always check your work when you've tried factoring something by just distributing it. So if I do 3 times x, that's 3x. 3 times negative 2 is negative 6, and that's what we started with. So we know we factored it correctly. All right, let me know if you have questions on that. I think I'm going to give you one just to try here. So I want you to try factoring this. Try factoring 16x plus 8. Okay, try writing that in factored form. That is the last thing for today. So come in with these notes done next time we have class, and I will see you then. Thank you. Bye.